Yeah, so here is now a video to conclude the video about the tube tester. All the components which I was describing previously, they are now built into my test station, and I will just demonstrate now how this is supposed to work. Okay, first of all, we have a tube here, ECC83. So I will switch on the whole unit, and I need to power up the direct current here, that is 300 volts. So with my variac, power it up and then switch it on. There we go. Okay, and then what I will do is I will use my meter here to check the plate current. It's milliamperes. I will use the ECC tube. You see it was gently glowing up, and now we should see this meter coming up. At the same time, we should see that the anode current should rise. Yeah, you see something's happening here. Of course, we have to. So that is 0.5 milliamperes. Okay, because now the grid is on -2 volts, and with that button labeled as G, I can now apply 0 volt to the grid, which should mean the tube is fully driven, and you see the meter is jumping to the good value. And let's have a look on the meter here. 1.7 milliampere, that's a good value for this tube. And what we can do is, with that one, we can switch between the two different systems. So we'll switch to the second plate. There's a little jump in the meter, so this system, the second system, seems to be a little bit worse. And on the meter we see we have something between 1.7 and 1.6. Again, switch here. Okay, so almost systems both work well, and in case I would not use this meter, then of course I'm just breaking here the anode current, and for that purpose I have this switch where I can bridge this meter here, and then we have the result again. So there's one more thing that's also possible to do. That is basically a static test of the tube, and what I can also do is run a dynamic test. For that purpose, I would then use my signal generator and my oscilloscope. Let's switch the oscilloscope on, and now we have the white signal here. It's coming from the signal generator. I'll put it here into input, and at the same time, I would use the output of the tube and the switch on the signal generator, and then we should have we should see some signal. Why not? Okay, what's happening here? Why don't we see anything? Great. Nothing's happening. Yeah, I should switch to the second channel. This is only I had it plugged here to the second channel, so we see already a big trigger on the second channel. And there we see the signal is coming. Yeah, take this one away. Yeah, so that is a nice result. basically what we could do is we could check also the input signal, just to see how much the tube is amplifying. What this one signal is, if I'm reading the scale here, 5, 10, 15, 20 volts. And just to check how much input I have from my signal generator, it should be significantly smaller. Yeah, it is. So now we're on a scale of 1, and we read 2.5 volts, roughly 2.5 volts, and the signal we were reading was 20 volts, so the amplification is 10 times. That is a good thing. Let's do it again. Plug to the input and the output and get the signal here. Yeah, very nice. So with that we have a both dynamic and static test of the tube. And let's see, I have another one here. Can also run it. Let me get my meter again. 0.6. I can just take this tube out. Try the other one. It's a bit complicated. Okay. Waiting for a result. Whoa, the meter is coming up. 1.4, 1.5. Okay. 1.6 seems to be also still a good tube. We can switch the systems. Ah, that is a little bit less. 1.4. Ah, okay. So this is not so symmetric as the other one. Let's try again. 1.4, 1.6. Okay. And from the dynamic test, let's see if there's any change. Well, dynamically, I can't see any difference between both systems. Yeah. So I would say this tester serves its purpose. It does what I was expecting, and I'm quite happy. Okay, thanks for watching. Goodbye.